next, a little bit more detail on electrifying high temp sort of industrial chemical processes. So over 50% of industrial heat is greater than 400 C. Cement, steel, fertilizers, chemicals, plastics, metals refining all need like 1500 C. So we need a solution here. Ultimately, it's purpose-built equipment that enables electrification. Carbon graphite is stable up to 2800 C. There's other options in the 1500 C range, like silicon carbide, other materials. So the idea here is you create and store heat when renewable power is available. If this is a sustainable energy economy, renewable energy is intermittent. Peak of the day, you've got more generation than you need. You make a bunch of heat then, and then you transfer that heat into the industrial process 24 hours a day using the stored heat you created when the sun or the wind was blowing. That's the concept here. And then on the hydrogen side, we also need green hydrogen to decarbonize metals and chemical refining processes. This is things like ammonia, making steel. There's roughly 120 million tons of hydrogen sourced from fossil fuel today to do these things. And hydrogen can also directly replace coal, which is currently used in a ton of steel production, through a process called directly reducing iron. You can replace blast furnaces with a hydrogen-reducing direct reduced iron furnace. And this is the way to eliminate fossil fuels from these aspects of the economy and the CO2 associated with them.
Yeah, so I mean, some of this, there's like room to disagree, but some amount of hydrogen is needed for industrial processes. My personal opinion is that hydrogen will not be used meaningfully in transport, and shouldn't be. If you're going to use a chemical fuel, you should use CH4, not H2. But nonetheless, it is needed for industrial processes and can be produced just by splitting water, essentially.
I mean, something that's been done for decades and decades. Yeah. This is not, rocket technology.
Yeah.
And lastly, a small part of the pie, but a necessary part of the pie, is sustainably fueling planes and boats. Shipping accounts for 3% of global CO2. It's ripe for electrification. Even with lithium iron phosphate, long-haul ships can be fully battery-powered. So that's a great opportunity to electrify. Energy density is a little bit harder for planes, but short-haul is doable today. With some improvements, we'll get long-haul underway. But even in the meantime, we can leverage sustainable aviation fuels produced and stored using excess renewable electricity. There's a lot of work going on in this space. And it's yeah.
Yeah, I mean, to really get long-range aircraft and long-range shipping to use lithium-ion, you need to redesign the ship and not just
or the plane.
And the plane to take advantage of the fact that it is a new source of energy. It's a different architecture. So. Just like with an electric car, you wouldn't just take a gasoline car and stick a battery in it. That's very suboptimal. It's much more efficient to have the battery be the structure of the car, and make it mass efficient and optimized for batteries. The same if that's done with aircraft, I think you can get long-range aircraft at around with cells at around 450 watt-hours per kilogram. Which you can buy it right now, actually. It's expensive, but I think that price will come down.
So when we stack up all of these efforts, we end up with the numbers we shared at the beginning of the presentation. 30 terawatts, 240 terawatt hours, $10 trillion. And you may be saying, like, I need some context. Is this feasible? It's entirely feasible. Just looking at it from a growth rate perspective, how much do we need to grow the deployment of these technologies? We're talking about only a 3x growth rate in solar and wind deployment. Solar is already growing at a breakneck pace, as is wind. This gap is going to be closed really quickly. When we look at electric vehicles, they have to grow 11x. Well, they grew 60% year on year last year. That growth rate is also going to close pretty darn. That gap is going to close pretty quickly as well. And lastly, storage. Tesla's energy storage business has grown at 65% CAGR since 2016. The global, energy storage business is accelerating pace as well. I mean, all these gaps are going to close, especially as this momentum of the transition to sustainable energy accelerates. And of course, our goal on this page is 20 million EVs per year and 1 terawatt hour of stationary storage per year. basically as soon as we can. And then, what about this investment? How do I have a reference point on this investment? Elon mentioned it's 10% of, 1 year's world GDP. Another way of thinking about it is how does it compare to what we're investing, like what we invested last year in the fossil fuel infrastructure? And it's 60% of that investment. So actually, building this sustainable energy economy is less than extending the fossil fuel economy from a year-over-year investment basis. So very doable. When we look towards, does this fit on the planet? Absolutely. Less than 0.2% of land. As a reference point, the total land area intensively farmed today is 12.5% of all land. So, I mean, you drive around, you see some farms, but you don't see them everywhere. This is an order of magnitude, more than an order of magnitude difference between farming and what we're talking about for sustainable energy land.
Yeah, and it doesn't need to displace farmland
Of course not, yeah.
Forests or jungle or any kind of ecological preserve. It can be used in very sparsely populated desert regions.
Yeah. Barren areas.
Yeah.
Areas that are just not really fit for development or otherwise used. So
yeah,
I mean, 0.2% can fit into a lot of places.
Yeah, there's essentially no meaningful ecological impact. In fact, transition to a sustainable energy economy would result in a substantial reduction in current ecological impact.
That's a great way to put it.
Yeah.
And what about on the mineral extraction side? So this is a cartoon that sort of gives you a sense for all the ore and the extracted minerals that are coming out of the earth every year. It's about 68 gigatons. So each truck is a gigaton. What does this look like when we're in a sustainable energy economy? Looks like that. The fossil fuel extraction disappears. We replace it with the materials required to fulfill the sustainable energy economy. It actually reduces. Now, it's not to say that we don't need to continue to explore, bring on mining and refining for the sort of specific materials for the sustainable energy economy. We do. But the investment and mass flows are all very achievable just looking at what is already happening on the planet. Like, this is nothing out of scale of what has been done and is already being done. And then when we calculate it on a sort of, element by element basis, the resources are there to support the transition. This is cumulative demand to move in the sustainable energy economy direction until 2050 relative to USGS resources today. We're not breaking the resource bank for any of these materials. And then when we look at what really happens as we move forward, history teaches the more we look, the more we find. What people think happens is, oh, there's this many resources, next year there's going to be less because we're going to extract them. What actually happens is, as we extract resources, we find more. And you can see on the right what has actually occurred with the key materials to the sustainable energy economy. Since 2000, as the sustainable energy economy has been growing and Tesla's been growing and all the industries around us have been growing, the actual resource availability has increased, not decreased.
Yeah, there still seems to be quite a bit of confusion about lithium. Lithium is extremely common. It's one of the most common elements on Earth. There's no country that has a monopoly on lithium. Yep. Or even close to it. There's enough lithium ore in the United States to electrify all of Earth. If the United States was the only place producing lithium, there's enough domestic material to electrify Earth. It's very common. The limiting factor is the refining of the lithium into battery-grade lithium hydroxide or lithium carbonate. That's the actual limiting factor.
And the same is true for these other materials. Yes. And this is, again, these are not like crazy technologies. It's just the investments need to be made, and the investments, they're not gigantic. They just need to happen.
Right. Nickel is maybe of them all the trickiest one to solve. But as we showed with the graph there, maybe need like 30% of the world's known nickel reserves. So
and the nickel reserves have actually grown since 2000. So.
There is more. Yeah, exactly. So. And you only need nickel for basically aircraft, long-range boats, and very long-range cars or trucks. But the vast majority of the heavy lifting for electrification will be iron-based cells. And iron is actually literally the most common element on Earth. So, a little trivia point, if you say like, what is Earth made of? By mass, it is made of iron more than anything else, and second, oxygen, and then everything else after that. So basically we're a muddy rust ball is what Earth is. So an iron cathode is sort of, you're definitely not going to run out of iron. There's so much iron, it's insane. So that's, yeah. So.
Yeah, and ultimately, this resource extraction, we go through this effort, we build these batteries, and then we recycle these batteries. So ultimately, we're doing this to build this sustainable energy economy, but the maintenance amount of ore that we require is really an order of magnitude or more, less, because of recycling. So in the end, a sustainable energy economy is within our reach, and we should accelerate it.
Yeah, I mean, so this is really the main message of today. And I really wanted today to be not just about Tesla investors who own stock, but really anyone who is an investor in Earth. And what we're trying to convey is a message of hope and optimism. And optimism that is based on actual physics and real calculations, it's not wishful thinking. Earth can and will move to a sustainable energy economy, and will do so in your lifetime. Thank you.
Yes. Thank you.